Welcome everybody to this brand new module looking at motion in 1 and 2 dimensions by SVGS Physics. All rights reserved. I wanted to just put up a quick reminder about what a scalar is and what a vector is. And I looked on images and found this beautiful picture from NASA that honestly explains exactly what I was hoping to get across. A scalar, as a reminder, only has magnitude, so that's just its value. When I say magnitude, I just mean a number. So a scalar will only have some number and its associated units, versus a vector having both magnitude and direction. So some examples. Vectors are displacement. This is how far am I from where I started. Versus a scalar might be the total distance traveled, and that's not listed on this chart here. Other vectors include acceleration, momentum, force, velocity, all that kind of good stuff. Versus scalars being pressure, mass, density, energy, and other things like that. This unit focuses a lot more on a few vectors. So, displacement is how far am I from where I began to where I ended. Velocity is the rate of change of where I am. So, how fast am I moving, essentially, at any given time. That'll be in meters per second. Kind of like your car traveling in miles per hour. But we're all about the metric system here. Also, under acceleration, that's how fast are you speeding up or slowing down. Really, it's just the rate of change of velocity. So we're looking at three different things, each one being the rate of change of the other. So displacement, how much does that displacement change? That's my velocity. At what rate does that displacement change? That's my velocity. At what rate does my velocity change? Well, that's my acceleration. And from talking with Mr. Klein recently, the rate of change of acceleration is actually called a jerk, which a lot of you probably called me upon completing your first lab report. But nevertheless, don't worry about remembering the name jerk. I'm not going to go as far as that. Now, if we're talking about velocity, a lot of people get confused about average velocity versus instantaneous velocity. Average velocity is just your displacement over time. How far away are you, and how long did it take? And that's okay for the big picture. Like I said, driving down 81, how long will it take until I get to Roanoke, Virginia? I can figure out how far I need to go versus the average speed, and I'll be able to calculate how long it'll take. So that's okay for problems like that. But if we're looking at where is something going to be and when is it going to be there, instantaneous velocity is a much better way to go. Now, instantaneous velocity is how fast am I moving at a certain point in time. At this moment, how fast am I moving? You can either observe it directly if you've got photographic evidence or something like that, or you can calculate it given some other variables. And that's what we're going to look at today. How do I calculate where I am at a certain time? How do I calculate how fast I'm going at a certain time based on other parameters of my motion? We're going to start with the position equation. This is good old d equals d naught plus v naught times t plus 1/2 times a times t squared, with only the t being squared there. Where d is your final position, a lot of times it's referred to as final position. I like to refer to it as its position at time t. Because if I'm undergoing some sort of motion, with this equation, you're not only going to be able to tell me where do I end up, you'll be able to tell me where am I at any given point throughout my motion. So in 1 second, 2 seconds, in 3.765 seconds, where am I? And that's what this equation is useful for. What's nice about it as well is that I really only need to know my initial velocity. I don't need to know my velocity at any given time because my acceleration takes care of that. So if I have, by the way, this equation requires a constant acceleration, but if I have a constant acceleration, then I'll be able to tell where I am at any given time just based on my starting velocity and starting position. And t is how much time has elapsed since I started measuring. And that's the position equation. I call it the position equation because the final result gets you your final position. We also have a velocity equation. So to calculate a velocity at any given time, I've got my final velocity, or my velocity at times t, in meters per second, will equal my initial velocity, also in meters per second, plus my acceleration in meters per second squared times time in seconds. So v equals v naught plus acceleration a times t, time. And then we've got this little equation that I like to call the combo equation, and I believe I made that name up. I'm not sure though. But it's basically, if I've got a bunch of parameters but don't necessarily have time, I can still figure something out about it. I may show you this in class, but basically it comes from the first two equations, solving one for time and plugging it into the other. You end up with your final velocity v squared minus your initial velocity v naught squared will equal 2 times my acceleration times my change in position. I write that as a delta d. So again, v squared minus v naught squared equals 2 times a times delta d, where delta d is a change in position. And you'll find this by just taking your final position, or your position at whatever time you're concerned about, minus your initial position. And that's just going to be measured in meters. So it's your total displacement. The last little bit I want to talk about in this video is free falling. Now, free fall is essentially when an object has no force acting on it except for gravity. So the moment it loses contact, the instant it loses contact with anything else, and only gravity's pulling on it, doesn't matter if it's moving up, down, left, right, up and to the right, up and to the left, down and to the left, doesn't matter. If only gravity is affecting it, it is considered free falling. So remember that. It is in free fall as soon as let's say I toss this pen that I'm holding straight up. The moment my hand lets go, it is in free fall. It's moving upward, but it's in free fall. Also, it has no acceleration in the x or horizontal direction, and I'll talk about that when we get to 2D motion. But the big point I want to make about free fall is at the top of its trajectory, so when I toss something straight up or when I drop something or anything like that, at its highest height, it always has a vertical velocity of 0. We're going to start with just one-dimensional motion, so we're assuming something moving straight up or straight down. Forget to the side right now. If it's moving straight up or straight down, it has a net total velocity of 0 at the top. Alright, so we'll be taking a look at all this and more when you all get back in. Have a great afternoon, evening, middle of the night, few minutes before class, whatever time you're watching this video. Hope it's a great time. Bye.